All right, thanks everybody. I wanted to make sure we had a chance to record this for David, so he could get all his hard work to the record, assuming you're fine with it being recorded.
Yeah.
If you're not, then we waste a lot of time.
It's okay. It's okay.
Okay, cool. It just goes up on the channel and you can step.
David's looking for a job, so he wants the resume.
Yeah, you want that.
Yeah, putting that on there.
You
Big
should.
green bold letters.
You absolutely should.
Try and live it.
All right, so thanks everybody. We'll go real quick and get started here. Whoa, I am at the end of it. Let's go to the start of the slides to start the presentation.
Fair enough.
So you're here, hopefully you know you're here for the meetup group. We normally talk about the microphones here, but they're not in use.
Oh, they are being used. It's fixed.
So
We're using the microphones again.
these microphones here are exceptionally good when people are speaking, the recording's going on. They will grab whispers and like zero in across the room to tell everyone your secrets. So just
Conversations in the back.
yeah, it's really great. So just be aware that that's happening. If you want to come speak at this meetup, should have looked this up. I think we still have, we kind of go through the end of the year because we're at the start of the month. I know the Kubernetes meetup is on the third Tuesday, so you get into the holidays, they kind of stop, but nobody does stuff at the beginning of October, November, December, so we're gonna still keep doing it. Since skip the first of the year, all that to say, I think I've got at least 2 months this year still open for presentations if people want to come speak. The ways you can come speak here, you can go to the paper call, you could just come talk to me or Brandon if Brandon's here, but he's out of town this week, and say, hey, I want to speak with Go Meetup. You can, honestly, the best way that's asynchronous is just to go to 4gutah.tech, go in the Slack channel, go to the Go Meetup and say, hey, I want to talk at the Go Meetup. Just go find the Go channel. People will connect you to the right place. That's easy enough to remember. If you're not on Slack, should be. That's where all the good stuff happens. We're continuing our theme of standard lib because there's so much goodness packed into Go that you just get when you install the language. You don't need npm and 2 gigs of Go modules to get basic things. Like it's all there. So I'm trying to go on a encourage people to speak and go on a whirlwind tour of all the stuff that comes with Go. We're going through a lot of it. In fact, in the Go channel, there's a canvas in Slack, which is like a wiki attached to a channel that lists all the packages. We're crossing them out as we go through them. So we're finally getting to strings. That was one of the big ones that we're waiting on. I think Funked is finally got someone taking Funked and context, but there's still HTTP. There's still, I think the OS has been done. There's a lot of like packages you might use every day, and if you're not an expert in those, feel like you would have kind of a vague idea of how some of these work. Volunteer, come speak, come learn a little bit more about them, help us deep dive on some of the stuff you may not know about. I know there's stuff in strings that probably at least one thing in the strings package that everybody here is missing, something that they've added or some stuff that I learned today as we were talking about the chat or chatting about the talk. Either work. Anyway, I want to keep doing those standard lib talks. There's also a nice slick Slack workflow based place to post jobs in Forward. So if you're looking for a job or you have one to post, go there. And it's kind of like a nice standardized form for finding jobs. Go West is coming up. It's coming up hard. It's coming up fast. This will be the second to last time I'll talk about it this year, because we only have one more Go Meetup before it happens. It is in this building, October 24th. Tickets are ridiculously cheap. Everyone here has them. If you don't, just go buy one. You can't get the food for that as cheap as you get. Like if you just want to come for lunch and then leave, like you could do it and it'd still be a good deal. Don't, but you could. The other one, I'll also plug DevOps Days. They do DevOps Days over at Slick, usually towards the spring. It's totally different org, but they're the same way. Their tickets are ridiculously cheap. Let's have really good sponsors or something, because they give you like 2 days and like 4 meals for really cheap. Yes.
I remember hearing rumor of something the day before Go West. Is that still happening or?
No,
I don't think so. I think it's
I am unaware of anything happening on the 23rd.
so just 1 day here, one day only in this building. So you already know how to get there, and I can't plug it enough. Great conference.
There's an after party.
There's an after party. Yes.
Also,
Also,
there will be alcohol.
yeah. And so add that to the list of like some food, some drinks for what is it like? I don't know what the price is. I won't even say because it doesn't matter. It's
$100.
yeah, it's ridiculously cheap. And if you can't make that, then come talk to us. We can,
Then your ticket's free.
so,
Buy the alcohol. Or you speak.
or yeah, come speak. Well, it's too late to speak, but speak next year.
No, we're fighting talk.
Oh, there you go. So if you don't want to pay the $100 to go west, come sign up for a lightning talk. Repurpose, give a talk here, repurpose it to go west. You write it once and you get benefits from it twice. And that's it. So I'm going to hand the rest of the time over to David. Thank you, David. If you talk about strings, string theory makes it sound like it's way more complicated than.
Yeah, so don't worry, guys. It's only gonna require a lot of brain power to do this talk, for me and for you guys. See. All right. String theory for Gophers. Welcome. You good? How we're good. So who is this kid? All right. A little angry at him, but who is this kid? So hi, my name is David Bosnick. I'm just some Eastern European guy. I was born in Germany and I came to the US when I was about 1 year old. Lived in Florida for about 23 years. And then I came over to Bosnia, lived there for about 1.5 years, hoping for a job. Now I'm in Salt Lake, living with my partner. She's at the U. She's getting her PhD in astrophysics. Pretty cool stuff. What am I? I'm a back-end Golang developer. I know you all see that hopefully, so don't worry about that. We'll get to that. I've pretty much done a lot of front-end work. I've done React, SvelteKit, all the JavaScript landscape stuff, but I don't really like it. I'd rather be a back-end developer. And most recently, I've been working on a TUI, a terminal user interface for Google Calendar. It's a wrap around it so you can have fun editing Google Calendar via my TUI. I'm a board game enjoyer. I like board games a lot. I think it's God's greatest gift on this planet. I've been playing Root recently, some Catan, and there's one more, but I forget it. I was thinking about doing a developer board game night for you guys. Hopefully in the future, once I get more established in Salt Lake, I'll try to get that going for you guys. And the by the ways, NeoVim, by the way, I really like NeoVim. It's my favorite way to go through text. It's my favorite way to work. Arch, by the way, I do use Arch, but I didn't vanilla install Arch. I actually used a fork of Arch using Endeavor OS. So I did none of the heavy lifting, but I get to claim that I know everything. So part one, we're going to talk about optimizing high-performance string manipulation through vectorized buffer pool allocation and zero-copy memory management strategies. You guys,
That's our first.
that's our first.
Okay.
So just be aware that this is going to be, okay, it's not really that bad. We're going to talk about what is Golang string. I know this is about the strings package, but I think it's good to have like a little emphasis on what an actual string in Go is. So yeah, so a Golang string is a collection of bytes that are UT8 encoded. You guys don't know what UT8 is? It's how we can get like those Russian characters, those Chinese characters available on the internet and around the world. Specifically, Go uses a rune system, which is actually an alias for an int32. That's about 1 to 4 bytes that represents a UT8 character. It's really important because when you just have a symbol, it's not just a single character in the world of Go. Go strings are read-only and immutable. So you can read them, you can't change them, and they're mutable, which is a more emphasis on can't change. I would like to mention that immutable specifically is you can't change it all, and read-only doesn't inherently mean that it's not. And then a string can be empty, but it doesn't mean that it's not empty. It could be nil. Right. So in the demo, a little bit of Go strings. I was told there's a delay, so I will try my best to explain this with the little delay that I have going on here.
Turn up the lights.
Oh yeah, dark mode, by the way.
All right.
So what I wanted to kind of talk about, let me move this up. So how I wanted to kind of explain some stuff was, if you look at like, say the word cafe with like the special character, do fmt.println, just do S1, it should work. Simply cafe, right? It's pretty simple, it's pretty nice, and it works. But what I wanted to talk about in particular was the length of cafe is not what you would kind of expect it to be, right? We're seeing 4 characters. Human instinct tells me 4 characters. It's actually 5. That's because Go uses runes. Again, that's the 1 to 4 byte kind of. Oops, we'll go back to it. It's the 1 to 4 byte size thing that allows you to kind of make these little characters exist. So technically, cafe is 2 bytes long. So if we wanted to actually see the character with bytes in mind, or with runes in mind, we can actually create a new variable here. We'll call it R1. We'll make it a type over S1. Copy that, paste it over, and then we'll go with R1. So now we get an actual representation here at 4. So that's how we human interpret it pretty nicely. Ironically enough, Go does it kind of nice. If you wanted to, you could go over. So if you do a for loop with like -b range over S1, and then we do fmt ln. We're gonna do print ln. We're gonna do S1. You actually see the byte representation of it. You would expect to go like, oh, I'm seeing byte 1, byte 2, byte 3. You're going to see like the actual letters, but no, you actually get the byte representation of it, which is again UTF-8 encoded. Pretty cool stuff.
Is that a decimal or is that a hex number that's spitting out?
Right, the decimal. It's an int. So like if I, for example, okay, I'll go like here. We can do fmt. Clear this one. We'll go over here. We're gonna do like S1. Oops, wrong direction. Sorry, Go. It's like the same thing, kind of. All right, we get at 67. All right, next up. All right. So basic kind of introduction to strings. Next, we're gonna you guys came for the string package. So the string package has a lot of stuff in it that's pretty self-explanatory. Like I said earlier, it's kind of dry. It's not much to go over, but I tried my best to go into what would be maybe niche use cases that might be helpful for some of you guys in maybe production style things. All right, cool. So we're going to talk about the builder type. So in Go, strings are expensive, as Todd told me earlier. Strings are expensive, and to kind of concatenation in general is a little bit expensive. So Go's solution to that, if you're doing a lot of concatenation, could be using the builder type. So builder in general is a type that is used to make effective concatenation. It implements the builder pattern. I know I lost somebody with that one, but it's how it is. And in the builder type in general, there's a handful of little methods you can use to min-max your string concatenation desires. Personally, we're only going to really talk about right string and the dot string, just because Builder has a couple shenanigans, and I just wanted to get through how it looks. And yeah. So we're going to go over here and go to this one. So we're going to go through this kind of, is that good enough for you guys? You want a little bigger? So a lot of you do this manual concatenation. It's good. So what we're doing is doing an S1, setting it to Go. And inside of Go's memory, every time you concatenate, it's copying, then appending. So when we go is, it's go is, copy, then append, and it appends and appends and copies and appends. If you remember earlier, strings are immutable. So every time you're appending, you're actually creating a new string. It's just kind of stuck in memory, like it's garbage collected later, but that's processing power that is used for your actual software. We don't want to use too much, but we're going to go ahead to see that it works. So yeah, Go is pretty cool. I think so. So I'm going to go back here. And so now what I'm going to do is try to explain how you would do this same kind of process through the builder. So we're going to declare a builder, and we're going to do strings about builder. There we go. Builder. There we go. So we declared builder as an item. You can name it anything you want, but to do the first part, we would do builder dot string, right string, and then we would just type in go. We're going to paste that 3 times. We're going to go into the first one is ready. Cool. And to actually create that string, because right now all this is doing is placing it in buffers. We're not actually creating these strings. We would just do FMT. We could put it in a variable. We're going to call it S2 actually. S2 equals builder dot string. And that actually produces the same thing we had earlier here. Boom. That was pretty cool. So again, syntactically, it's a little bit more, but it's pretty simple overall to look at. We're going to go back just to show that. Again, creating the builder, writing, builder.string actually creates the string, and then we're just printing it out. I missed that part. Don't worry about it. So some min-maxing techniques that you can use to kind of like prove builder's quality. So there's a .grow method inside of builder. So whenever you create that builder variable, you can use .grow with an int that actually changes. You can manually add to the buffer size. The point of this is if you know how much data or how big the data you're going to actually put in is, you don't have to let go do it automatically. You can manually do it, which adds a little bit of performance. You can use .reset to clear out your buffer if you're like, I don't like it anymore. I don't want to get out of it. Do it however you want. Sprintf, you can do it inside the right string. So if you're looking for some formatting stuff where you're like, oh, do I put a space here? Do I not put a space? You're actually effectively not struggling in that. Yeah.
So two things. One question, one comment. Question one, can you explain why right string is more efficient? Do you know what it does under the hood that makes, or the builder more efficient?
Yeah.
Concatenation.
I'll get into that the next slide, but I can say it early.
No, wait for the slide. That's fine.
Yeah. Well, okay, I'll just say it. The reason builder is more efficient in creating it is because the actual buffer that you're creating isn't using string data, it's just using the byte information. And so you don't have any of the string internal struct using length, because the internal struct of a string in Go has length and the actual pointer to the location of memory. You don't actually have to do any of that. You just have, it's pretty much just an ever expanding array that you can. What was the comment?
Sorry. String builder, I think, is a IO writer as well. So instead of using sprintf, you can just use fprintf.
Not too sure.
I'm pretty positive.
That is correct.
There we go.
So it's a minor thing, but at least you just have a slightly more concise.
Yeah, more.
Right. You don't need to write string and then add this printf. It's just printing instead of printing into a file, you're printing into the buffer.
Into the buffer. Yeah, yeah. So
and the linchers will actually warn you about that.
There's a lot of places I could use that.
Yeah. Modern linchers will just tell you you can replace one for the other.
they're live. Okay, pros and cons. So pros, it is much faster than manually appending. If you're the best use case for it, I would say is if you're appending in a loop, because normal appending is probably O of n squared. It's a little taxing if you have really, really large strings that you want to create. But again, builders that big NO, a little nicer. Cons, Todd told me this, readability goes down. It kind of looks like an eyesore to look at sometimes. Right, we're creating all these this is so nice, so clean, so elegant. All this beautiful line of code. And this looks a little convoluted, but in the grand scheme of things, I think it's manageable. Overestimating your .grow buffer is kind of bad. You don't really want to do it. If you do happen to do it, all that's going to happen is you're just going to have this fat stick of memory that the garbage collector will not clear. And so you're kind of making your thing less effective in that way. All right. Use cases. So generally, for complex structures and large strings, again, you're this is for concatenation. You're trying to make large, big strings. So HTML, XML generators, if you're doing a static site with a lot of nodes going in and out, you kind of want to think about using string builder. If you're into the builder architect, you can do it for SQL queries, building queries to make them more faster, more rapid. Again, we're making performing code. And any kind of large logging, like if you're trying to append to your files forever, it's pretty nice to have it a little bit faster. Well, it's actually a large case faster. We'll kind of show that here. So we're going to go into, we're going to show a speed test. And generally what's happening here is I'm doing 2 loops. I actually didn't know this till recently. Thank you, Internet. You can use underscores. Go ignores underscores for numbers. So if you're like doing fancy numbers, you can do that. That's pretty nice. It's just taking the time for now. We're going through a for loop, 10,000, adding go to it. Then we're doing a second time just to make sure and printing the time difference. And the same thing using the string builder. It should be good to go. So again, 28 milliseconds for just concatenation, and then 62 nanoseconds. So it's pretty big. Like I think the number was like 80 times faster, but I think it just depends on how much you're adding. The more you add, the faster it's going to be. The more results you're going to see.
And that might be radically different with like giant strings.
Yeah.
You're getting small bits, and then you may get even more orders of magnitude if those
Yeah.
were.
And so it's like
together.
exactly. So like large files, it's like really important to like make sure if you're creating like large strings, it's good to use the builder because it's substantially faster. Up
If you're
next,
doing it on the same line, it abstracts that away into something more efficient though. Like it's just in a single line and you've got 4 or 5 plus signs to concat.
Oh, I see. It's just easier to read that vertically than with the plus signs. What you're saying?
Yeah, if you're not repeatedly writing to the same var and you're doing it in a single invocation, that is optimized.
You're saying that compiler optimizes it, or?
Yeah.
Okay.
yeah. So up next, strings.clone. Pretty big stuff. I like strings.clone. I didn't know that until I came into this doc. So strings.clone literally just takes a copy of the string that you put it into and puts it in its own place in memory with its own array and its own little slice. So you're not actually taking the original string. Because when you use strings, again, are immutable and read-only. So when you declare a string in Go and set it equal to another string, what's actually happening is that the second string is just pointing towards the first string. It's not actually going to create a new string for memory efficiency. As well as, I'm going to allude to this, if you're taking a small bit of a string, so if you have a huge string and you're taking a small bit of it, that string, second string, is taking the entire string into account, which is pretty big. Strings.clone has, again, very specific use cases, similar to Builder, but Builder I feel like is more readily available. Clone is very specific. And exists because of the way the Go garbage collection works. Pretty cool.
So can I extrapolate that and ask that in form of a question?
Sure.
So you're saying I got a string that's 10,000 words long.
Yes.
And I slice that string in, and I say I just want to take the first 6 characters out of that 10,000 word, just like the angle brackets :6. Put that in string B. String B still is somewhere in memory. There's still the entire 10,000 words. Even if string A can get cleaned up,
You can't get cleaned up.
A reference goes away, but like the underlying.
Yeah,
So that's what this clone would do. You'd be like, copy it, now clone it, and that clone is actually standalone, and so the old big thing can go away.
Yes, because like right now, if I take like a, if I do S1, or I can, we'll show an example, but if I take like S1 and S2, if I do S2 as a small section, actually, we'll just.
Yeah, sorry, this is a really interesting use case. It's like super nuanced, but
Yeah, so anything about the terminal, we'll go back into it. So if we go into my clone one, I'm talking specifically like this. We're getting a big file in, and we're actually just taking a small subsection of it. Say we know the bounds, we know the index that we need in particular. When you actually manually do, let's say like small copy, equals, I'll do. If we do like that, what's actually happening is once this actual function ends and the garbage collector starts clearing out variables that aren't really being used, small copy still, it doesn't reference the original string. It references like a small part of it, but the Go garbage bounds stay into place. So if you import a 10 megabyte file, and then just take a small snippet of it, Go will still have the 10 megabyte long string in its mind, even though you're just using a small subsection of the string, which you don't want to do that.
I feel they just do that to make slicing strings like that faster. Otherwise, it's doing all copies all the time. It's probably not.
Yeah, because it's again, it's like optimization. Because if I just have to keep on declaring new strings, I'm like, again, immutable. We don't want to fill out our memory. We don't want to like blow that up. So it's just to have, it's just a not a bandage fix, but it's a fix for having those incredibly large files. Okay, so again, pros, if you're getting a really large string, it's getting garbage collected if you just use git clone, or not git clone, but go clone, or strings.clone. You're actually just taking that subsection and you're not actually dealing with the entire string. Again, Go, if you have a string, copy another string, the first string doesn't just magically go away when you stop using it. You're creating a unique string. So I've heard there is some use cases. Now, I don't personally ever needed to do it, and I was having a hard time figuring it out, but apparently it's also good for concurrency in a very rare case where you want to have separate places in memory when you're using Go concurrence functions. Kind of a con, it's pretty unnecessary most of the time. You can kind of get away with just doing small little strings here and there. And you're very rarely going to use Go clone or strings.clone. And honestly, if you use it on small strings, you're just wasting memory at that point. Use cases, again, large file processing. And if you wanted a non-share buffer, as well as data extraction for a large CSV file would be like a use case that's like a little bit more practical. You have like a huge thing from your company, and you just want like one little cell instead of having 10 megabytes in your string buffers. Mini part 3, an honorable mention. Yeah, so equal fold is pretty cool. I didn't think about it being as cool as it is, but it's a very small thing that all it really does is it does a case insensitive checking of 2 strings, and it returns a Boolean statement saying like, are they the same? Are they not the same? The interesting thing about it that I thought was really cool was I didn't know Greek letters had 3 cases. They have upper, lower, and final form. And if you use equal folds, it takes all of those into account. You're never going to do it. If you do it, call me, but it's interesting enough on its own. Conclusion, pretty much Go string builder is really cool if you want to start concatenating, want to do all that kind of jazz with really good memory efficiency. Again, strings are costly. You don't want to keep on appending them. They're immutable. You're just causing more and more problems. And Go clone, really good for those large files, and you just want to cut them up nice and small. And in general, I didn't talk about a lot of parts of the strings package because again, it's a lot of it's self-explanatory. But I would like try to tell you guys to look into it because there's always like with the packages in Go, there's always something you should never expect. And any questions for me? Pretty. Yeah, I guess. Yeah, go for it.
When you looped over the string using range, were you looping over the runes of the string or the bytes of the string?
You can loop over the rooms.
Oh no! My bad. If you use range, it goes over the actual. If you use range, it goes over the runes, not the bytes.
I think only if you cast it to a slice of room.
Yes, if you use range, and that's why you can do like.
Can you go back to your cafe example and make sure it didn't print 5 lines? I swear it printed 5 lines.
It did.
We have the ability to.
Well, one was the length.
The technology.
Oh, maybe one was the length. Okay, that's
It was 5
'Cause
lines, but one was the length.
Yeah, the last rune is one, but it's still one. Right.
It's 4 runes, it's 5 bytes. And the rune, each rune has an integer
file on its own.
value.
It's
So like the last rune with the
your clone file
accident
when you do
E.
it when you're
Oh,
running,
yeah.
running all the Go files. Do it.
Yeah.
Do go run main.go.
Oh Jesus Christ!
4.
I
Okay.
don't have my sensor button, sorry.
It's 4 values, it's 5 bytes.
Yeah, I remember it does go by.
Yeah, it goes by
I was
root.
looking at a merge request today that was doing a bunch of string manipulation. I'm like, you should probably cast this to a slice of bytes first or use a string builder because you're doing a ton of allocation
Yeah,
here.
yeah. And I figured that out because they did it because they want it's an easier time to deal with it, like working with rooms.
And this works because
So if you know ASCII, you know that there's only 7 bits of values. And so everything above that is not a valid character until you choose a character set. And so if you're looking at the integer value is going to be 233 for that rune.
for that, so
That
that
some code point that isn't an ASCII value at all. But like it's going to take that and it's going to represent that in 2 different bytes because you can't just flip the first bit and say like, oh, it's 233 and get that because now you're choosing a code point.
Yeah, because if I do like length of like S1, then we'll do like -1, and then we'll like do that. You actually get kind of like, Jesus, you get like how about that? Let's do string interpretation. You actually get that funny character right there. Because he takes 2 bytes to represent the rune of the E with the accent mark. Yeah, go for it.
I thought I'd maybe clear it up a little bit because I had to spend way too much time working on this stuff. So the confusing thing about strings is the UTF-8 piece applies to string literals. So you can't write like an invalid UTF-8 string literal. You can have invalid UTF-8 strings all over the place, right? Like you don't ever get a runtime explosion if you cast like a string to a slice. But you can't construct via a literal a string that has like a /0 in it, because that's the whole point of UTF-8 is to be compatible with C's like Sterling null terminated string setup. So it's basically all a string is 2 things: a read-only slice of bytes, plus if you range over a string, you get runes. So it actually gives you, 1 rune at a time. And I wasn't even sure about this, so I had to double check it. Because Unicode gets crazy with like code points and graphemes and other things I don't really understand. But apparently 1 rune is enough for any sort of code point. So even though UTF-8 is variable width encoding, nothing exceeds that like 32-bit rune. But slicing, you still get 1 byte at a time, which is why you get the wackiness there. Because you're just grabbing a single byte.
Because the
accent.
is like 1 to 4 bytes. Yeah, and I honestly, whenever I was all this stuff, I didn't. It was kind of interesting that I think I read it on the Go docs on the string specifically, not like the Go string package, but the actual quotation mark is what is doing the encoding. I think is of the UTA, which is interesting.
And we're part of the spec, like source code has to be valid UTF-8. The things between the double quotes are valid UTF-8 because the source code has to be valid UTF-8. Can throw escape characters in there, but like you can't put invalid UTF-8 escape characters in there. Like you can't in a string literal throw in a /0. I think like all of us have probably thrown in like a /n or something, or you have to do the full on like /u XYZ and put in an actual, I guess it's a code point.
you think if I build a byte slice and then put string around that, I could build myself all sorts of invalid UTF-8.
Yes.
There's nothing that will blow up at runtime if you cast your byte slice to a string. Think about that. Have you ever seen a runtime panic for casting back and forth?
I have not actually, but I believe that can happen.
Although it could
won't panic
in
that.
wacky ways. So the JSON package does this. When it deals with some things, it'll actually take invalid UTF-8 bytes and do like this thing that's like a UTF-8 replacement byte. I forget its value, but like it looks like a really weird jump if you've ever ran into it. Because all of a sudden your code that wasn't valid UTF-8, when it comes out as valid JSON, essentially has some bytes in there that means it's sort of like not a number, it floats. It's like sort of a signal value that's like, this is UTF-8 that's validly invalid. It's what we put in here is, we had something else that didn't make sense.
It's here's your prize. You broke UTF-8.
Yeah.
Like one of those characters you get if you accidentally cat a binary on the terminal, and you get
If you try to like JSON code,
question mark.
If you had, okay, if you took a random crazy byte slice, turned it to a string, put that into a struct, and Jason decoded that, or Jason encoded that, I expect you'd see the replacement character. I could be wrong, but it's a fun thing to test, but that's my understanding.
Is there any other questions?
I was gonna say, the standard lib also has a Unicode and UTF-8 package that has more rune introspection stuff.
You want to do the next talk on that?
No.
Is there?
Those are not done yet, if anyone wants to follow it up.
For that equal fold thing, like besides the weird 3K streak things, is that just a little bit faster than
70% faster.
okay.
If you're doing your normal computer science fresh out of college, dot lower on both of them, setting them equal to, it's not as fast. Doing equal fold is like 70% faster, which
Okay.
is pretty cool on average.
Assuming you don't want to also just cast the lower to keep it lower.
Yeah, because it automatically checks in for cases, which is super useful.
Yeah.
Anything else? Hang on.
I see German also does strange things like having different forms of lowercase letters. So the canonicalized version of
Okay, well,